Okay, so today we are still continuing on with the prerequisite chapter, still in lesson 5. This will be day 3. So when you go to look for your homework on WebAssign, it's going to be P5C. And today what we're going to do is add and subtract rational expressions. So essentially, we're just adding and subtracting fractions. So when you add and subtract a fraction, if you remember back from 4th grade when they probably taught you how to add fractions, you must always remember to find a common denominator. They must have the same denominator before you can add or subtract fractions. For these, they're not going to just be numbers, they'll be expressions, and you're going to need to factor the denominator first before you find your LCD. If you don't factor the denominator first, you're going to get a huge, ugly denominator that you're going to have to go back and simplify in the end. So always factor the denominator first. Now, when we find the LCD, if it's just two separate binomials that are in the denominators, the LCD becomes both of those. Now, if it's a variable, let's say you have an x and an x squared, you would always pick the variable with the higher degree. So the LCD would include an x squared. Then once we find that LCD, we have to multiply each term by what it's missing from the denominator. So whatever you multiply to get as the common denominator, you also have to do to the numerator. Once you find the common denominator, then you're just going to add and subtract your numerators. And then the LCD stays the same. So let's go ahead and take a look at some examples. So the first two examples look like a 4th grade math problem. So all we need to do is add these two simple fractions. We need to find a common denominator, and we're listing the multiples of 2 and the multiples of 3 until we find the denominator that is in common, or the least common multiple. Now remember, we're multiplying to get that. We're looking at multiples, so I can't just say, I'm going to add 1 to the 2 to make it a 3, so it's a common denominator. You don't add to make a common denominator, we're multiplying. So my LCD here, if you start looking at the multiples of 2 and 3, multiples of 2 would be 2, 4, 6. Multiples of 3 would be 3, 6, 9. The one that is in common, that is the smallest, is a 6. And remember, whatever we're going to multiply to the denominator to make it become that LCD, we're going to also multiply to the numerator. So I'm going to multiply the 2 by a 3 to make it a 6. So whatever I do to the bottom, I do to the top. And then the same thing over here for my 1/3 fraction. I'm going to multiply that denominator by 2, and whatever I do to the bottom, do to the top. Now that I have the LCD, all I need to do is add those numerators, 3 plus 2, keep the LCD, and my final answer here is 5, 6. Let's try the second one. Still nice and easy. I'm going to look to find my least common denominator. And again, it always has to be at least as big as the biggest number. So my LCD here is going to be 12. My second fraction already has it, so I'm just going to leave that one the same. But the first fraction, in order to make 6 a 12, I'm multiplying it by 2. Whatever I do to the denominator, do to the numerator. Now that I have the LCD, all I'm going to do is add those numerators, keep that LCD, and I get 3/12. Always simplify your fractions after you add them. I can reduce both of these by dividing it by 3, and my final answer is 1/4. So for example number 3, we now have an expression that is our denominator, but notice it's already in common. It's the same. So I'm going to go ahead and just add my numerators because it already has the LCD. It's x plus 1, and then I just add 1 plus 2. So my final answer is 1 plus 2 is 3 over x plus 1. So when it's a subtraction problem, just like with the polynomials, it'll help if you think about this as a keep, change, flip. Okay, because everybody's going to remember to subtract the 2x, but then you may forget that you're really doing subtracting that -3. So what I like to do here is I already have the LCD, it's the x plus 2, but for my numerator, I'm going to keep that first one the same, so it stays x plus 1. I'm going to change this symbol in the middle to a plus sign, and then I'm going to make both of these signs opposite. So it becomes -2 plus 3. So I'm distributing or changing the signs. You can think of it either way. All right, now that I have my numerator with the sign switched, I'm going to combine my like terms. So I have 1x minus 2x, and that's going to give me -x. And then I can add the 1 plus 3, and I get 4. And then I have the common denominator. And you're done. Do not try to simplify the 2 and the 4. Remember, this is attached. So in order to simplify, you need to find an exact match. So nothing simplifies here. You can't say I'm going to cross off the x's and leave behind a -1, and I can't divide 4 by 2, because again, in order to simplify, I would have either needed an x plus 2 in the numerator or an -x plus 4 in the denominator. So for example 5, notice they both have different denominators. I need to change these denominators so it's a common LCD. So notice the first fraction has an x, the second one has a 6. So in order to get them to have a common denominator, I'm going to multiply my first fraction by a 6. So when I multiply this by 6, then I have this LCD of 6x. Second fraction is good. It had the 6x, but the first one needed that 6, so I'm going to multiply 6 times 1. Now I'm going to add the numerator, 6 plus 5 over the LCD. 6 plus 5 is 11 over 6x. All right, for the next one, remember, when we're trying to find an LCD, we're not adding anything, we're multiplying. So just like I showed you before with the example of the 1/2 plus 1/3, I can't just say I'm gonna add 1 here to make it 1/3. Same thing here. I can't just put a plus 1 and then a plus 1 here. It doesn't work that way. We multiply to get our LCD. So in order to get the LCD, it's actually going to be both of these. It's going to be the x and the x plus 1. So my LCD is going to be x times x plus 1. I'm going to go ahead and write that down for each one, then the plus sign. So now my first fraction, notice what I needed to do to get that x plus 1 in the denominator is multiply by an x plus 1. So I'm going to multiply both the numerator and the denominator by x plus 1. Now what was here was a 1. So really what we're doing is distributing the 1 to the x plus 1. But really that doesn't change anything. And then over here, this guy's missing the x. So you're going to multiply the 1 to the x. Now, do not go back and say, well, can I cancel this, cancel this, cancel this, cancel this? It doesn't work that way. It just goes back to your original problem. Okay? So when you're adding and subtracting, when we're trying to get that LCD and multiply the same thing to the numerator and the denominator, don't try to cancel things. You have to distribute and combine like terms first. So I'm going to go ahead and, because both of the numerators had a 1, really all I'm going to do is rewrite that. So it's the x plus 1 from this one, and then plus the 1 times the x is just x. The numerator, I need to combine those, but the denominator stays the same. It's the LCD. So now I can add my like terms in the numerator. 1x plus 1x is 2x plus 1. And then write your LCD. You do not need to multiply or FOIL if it happened to be two binomials. You can leave it in factored form. Again, nothing is canceling here because remember, this is attached. So do not try to cancel these x's. It doesn't work that way. I would need an exact match. I would need maybe an x on the outside, then I could cancel. But because that 2x plus 1 is grouped together, don't try to cancel the 1's or any of the x's. Keep in mind that if they ever give you a question like this on an SAT, they could distribute it. So you might see it written as, let's say they did distribute it and say that the final answer was 2x plus 1 over x squared plus x. Yes, that could be another version of the answer, but you always want to factor what you get, just like that way you're going to look to see if anything cancels. And you're going to leave it in factored form. For the next one, number 7, notice I have two separate binomials. Again, I can't add anything to make them in common. So my LCD is actually going to be both of them. It's going to be the x plus 2 and the x minus 4. So let me go ahead and set it up. X plus 2 for each one, and then an x minus 4 for each one. Now what I'm going to do a keep change flip up here, and I'm going to make this a -3. So then when I go to fill this in, I'm going to put the 1 that was there and then the -3 that I just did keep change flip with. So now I'm going to go back and look. What was the first fraction missing? It was missing the x minus 4. So I need to multiply this 1 times x minus 4. The second fraction was missing the x plus 2. And I need to distribute now that -3 to the x plus 2. So I'm going to go ahead and don't try to cancel anything. We have to distribute and combine like terms. So 1 times x minus 4 just stays x minus 4. So the first fraction's numerator is going to stay. Then the second one, I'm going to distribute this -3, and this becomes -3x minus 6. I'm going to just write the LCD down here. X plus 2, x minus 4. I need to combine my like terms in my numerator. So I'm going to combine the 4, I'll do the 1x minus 3x, which gives me -2x. And then I'll go ahead and combine the -4 and the -6. Write the LCD. We're not foiling this. We're leaving it factored. Now, what you need to do is go and factor the numerator to see if anything will cancel. So what I need to do is take this numerator and I need to factor out a GCF. So -2x minus 10. I can divide these both by -2. So then this will become -2 and then x plus 5. And then it has the common denominator. Now, because factoring it did not get me anywhere, it did not get anything to cancel, I would accept on the test either answer here. So I would either accept it like this or like this. Now, if you forget to factor it and there's something that cancels, you will lose points. Okay? But this is why it's always very important that you're showing your work. Okay? And then that way, if then the last step you forgot to factor it to see if something canceled, then you wouldn't lose everything. Okay, so again, you're multiplying to get the LCD, And then if there is something in that numerator, you need to distribute it first, then combine like terms. And then once your terms are all combined, check to see, can you factor what remained in that numerator to see if there's anything that will cancel with the denominator. If not, you just leave it with the trinomial over the two binomials. Now, keep in mind on an SAT, they may FOIL that denominator and leave it with a trinomial on top of a trinomial. However, for your test and for WebAssign, leave it factored. Don't FOIL it out. All right, number 9. Again, my LCD here is going to be both. So it's going to be the 2x minus 1 and the x plus 2. Again, I'm going to do the keep change flip at the beginning and make this a -1 right now. So my LCD, 2x minus 1 for both, and the x plus 2. Plus sign. It's got an x here, and then it's got the -1 there. All right, so now the first fraction, notice it's got the red one, it needs the blue one. So I need to multiply the top and the bottom by x plus 2. The second fraction is missing the 2x minus 1. I need to distribute that -1 in there. So let me go ahead and just write it here for now. So now remember, do not cancel. Distribute, combine like terms first. So over here, I'm going to distribute the x to the x and the x to the 2. I end up with x squared plus 2x. Over here, I need to distribute the -1. So I get -2x. -1 times -1 is +1. I still have that LCD, the 2x minus 1, and the x plus 2. I need to combine like terms in my numerator. Notice nothing to add to the x squared, so I just write that one down. Notice here, 2x minus 2x, this is gone. And then I just have the +1 over that common denominator. Notice I don't have any matches, so nothing cancels. And that's your final answer. Factor first. So that's the difference of two squares. So I'm going to factor this first fraction, and I'm going to make it x minus 3, x plus 3. Second fraction, I'm just rewriting. All I've done is factor the denominator. Notice what happened. Notice they both have in common already an x plus 3. So now the only thing the second fraction needs is the x minus 3. So my LCD isn't going to be x squared minus 9 and x plus 3. It's going to be, break it down first so you don't have the x plus 3 twice. So my LCD, x minus 3 in both, and then the x plus 3 with the plus sign. This one, you don't have to do keep, change, flip. And then this one had a 2 and a 4. The only thing I needed to change now was that second fraction, and I had to put the x minus 3 to both the top and the bottom. Now I need to, don't cancel, distribute and combine like terms first. So the first one, the 2, nothing to distribute to. The second fraction, I need to distribute the 4. And then I still have the LCD, the x minus 3, and the x plus 3. I now need to combine my like terms in my numerator. So I can combine 2 minus 12, and I get -10. And then I have the plus 4, x. Now, you can also write it, which would probably be better if you put the variable first, but again, it doesn't matter. So I'm going to flip it around. I'm going to put the 4x first, minus 10, and then the x minus 3, x plus 3. Now, factor the numerator, see if anything will cancel. I can factor out a GCF of 2. So after I divide the 4x by 2 and the 10 by 2, this is what remains. And then I still have my LCD. So x minus 3, x plus 3. Nothing cancels. So I would accept either the unfactored numerator or with it factored. But factoring it didn't get me anywhere. Now, on an SAT, they may FOIL this and put it back as 4x minus 10 and x squared minus 9. They may FOIL it back to get the difference of 2 squares. So just be aware of it when you're taking the PSAT next month or the SAT going forward. So here's 3 fractions. Factor first. So the first one can't be factored. So let me just rewrite that. So I have 2 over x plus 1. Second fraction, you can't factor it, but the third one we can. I'm going to factor it, difference of 2 squares, x plus 1, x minus 1. If you don't factor it, then you may think, oh, it's all 3 of these, and then you're going to get a huge, ugly, big problem that you're going to have to go back and simplify in the end, and it won't be pretty. So instead, factor first, and this is my LCD. And the first 2 fractions already have part of it. So my LCD, let me go ahead and write it down 3 times. So x plus 1 for the first, the second, the third, and then they also need the x minus 1. Now, the last fraction had everything it needed after you factored it. So I just put the 1 back. The first fraction is missing the x minus 1. So whatever you multiply to get the common denominator, you also have to do the numerator. So we're going to distribute the 2 to the x minus 1. The second fraction had the 2, and it was missing the x plus 1. So let me put that here. Now, do not cancel, distribute, combine like terms first. So the first fraction, once I distribute the 2, becomes 2x minus 2. The second fraction, when I distribute the 2, becomes 2x plus 2. And then the last one, it didn't need anything multiplied. It had both binomials. So let me go ahead and write that down there. This is the first one. Here's the second one. Combine your like terms. So I have 2x plus 2x is 4x. And then negative 2 plus 2 is 0. And then 0 plus 1 is 1. And then it's over that common denominator of x plus 1, x minus 1. Nothing cancels. Now, again, on an SAT, they may FOIL that back and make it x squared minus 1, but on the test next week, leave it like that. But be aware of the 2 forms moving forward for a standardized test. All right, so for this one, here is the problem. 6 minus x over x times x plus 2, x plus 2 over x squared plus 8 over x squared times x plus 2. Now, on that very first slide after the title, remember it said that you would always look for the largest exponent as your LCD. So out of the x's here, the greatest exponent is an x squared. So my LCD is going to have the x squared. And then it's also going to have this binomial. So that's my LCD. So let me go ahead and write that down for all three. And then I'm going to put what was up there. So this had that. And then this one had x plus 2. And this one had the 8. Now, the last fraction had everything it needed. It had the purple one and the red one. Notice the first one, it only had part of the purple. So what we need to multiply to get it to be an x squared is an x. And then for the second one, it's missing the red, it's missing the x plus 2. So now, do not cancel. I'm going to distribute the purple x to the 6 and to the negative x. So 6x minus x squared. For this one, I got to FOIL these two. So this will become x squared plus 2x plus 2x plus 4. Add the middle. So it becomes x squared plus 4x plus 4. So that's what's going to go on the top here. And then the plus 8. And then it has the common denominator of the x squared times the x plus 2. Now go back. Combine your like terms. I've got like terms here. Negative x squared plus x squared. It's gone. So this is gone. Then I'm going to go back and look for my x terms. So I have a 6x and a 4x. That'll give me 10x. And then I'll go back and grab the constants, 4 plus 8, and that's 12. Put that on top of your LCD. I'm going to factor that numerator to see if anything will cancel. I can factor out a GCF of 2, and then I'm left with 5x plus 6. Nothing ends up canceling. So just leave it like that. So you can either leave it like this or like this. And that is it for the notes on adding and subtracting.